All right, lesson 107, volume and surface area of compound solids. I'm going to do my best today to take something that a lot of 8th graders don't like in geometry, volume and surface area. I'm going to try and make it a little simpler for you. Not quite sure if I'm going to be that successful, but we'll give it a go. Here we go. This figure is composed of 1-inch cubes. We're going to find its volume and its exposed surface area. So excluding the base, okay? So we're saying that it's sitting on its base, it's not exposed. So let's go with the surface area here. So the volume, first of all. Volume's a little bit easier because all we have to do is take level 1 and add it to level 2 and add that to level 3. Level 1 has got, the bottom anyway, has got 9 boxes. It's 3 by 3, so 9. Level 2 is 2 by 2, and level 1 or level 3 is obviously just the one box. So the combined volume of this is 14 units cubed, or 14 1-inch cubes, cubic inches. Okay, as far as the surface area goes, a little bit more complicated here. We need to look at, again, the front, the back, the left side, the right side, and the top, and we're not going to include the bottom. But so the front is 6, and I'm marking those off here in blue X's right now. Okay, so the front has exposed surface area of 6 square inches. The back is going to be basically the same 6. The left is 6 and the right is 6. The right, I'll mark those, why not, in green here. 1, 2, 3, 4, 5, 6. Okay. And the left would be basically the same kind of shapes showing. And then the top, I'm marking those with those blue lines, is 9. So the total surface area, you just add them all up, and it's 33 cubic inches. So not a whole lot going on. You just got to be able to break this up into parts and add those parts together for the surface area and for the volume. All right, how about number 3 here? Again, to be quite honest with you right now, this is one of the more ridiculous problems that we've done all year. But it'll definitely illustrate the point of what we're doing here with compound volumes. So we're going to find the volume of this building. Then we're going to find the total area of the building's rectangular walls. The walls aren't so bad, but the volume is definitely a pain. Here we go. So to find the volume of this thing, the first thing I'm looking at is this rectangular prism that I've kind of outlined here. Kind of missed a line too, but so the base of that rectangular prism is over here with the top view. So we'll do the area of the base times the height. Now the area of the base is kind of tough too, okay? We've got this rectangle that I just marked off here. It's 36 high and 16 wide for area 576. And then we got this rectangle over here that's 20 by 16, and that's 320. So the total area between them would be 896, and the height of the walls is 10. Okay, so the area of the base is 896. That was kind of tough to figure that out, and the height of the prism is 10. So that's 8,960 square feet. Excuse me, cubic feet. All right, so we're not done yet because we've also got a roof on this thing. I'm going to look at this like I've got this triangular prism right here. Okay, so again, we're just going to do area of the base times the height. The area of the base is this triangle, so I'm going to do 1/2 of 16 times 6, which is 48 for the area of the base. And then its height is 36 here. It's this distance from triangle to triangle. So 48 times 36 is 1728. Now, next, we've got another triangular prism going this way. Luckily, it's got the exact same dimensions, so The area of that is 1728. But here's the problem is we've got this triangular prism where those two, I'm sorry, this pyramid where those two triangular prisms overlapped, and we double counted that. We counted that twice. So what I'm going to do is I'm going to find the volume of that pyramid, 1/3 base times height. The base up here in the black is just 16 by 16. So 16 squared is 256. And the height is the same as the height of this triangle, 6. So what do we got? 512 for the area of that. Now I put addition here, but it's not addition, okay? It's actually subtraction. I'm fixing that right now because we double counted it and we only needed to count it once. So we're going to subtract that off. All right. So we'll add all those up, and the volume is going to be 11,904 cubic feet. Like I said, one of the more ridiculous problems we've done all year. That whole double counting the pyramid there. Now the lateral surface area, not nearly as tough. We're just going to take the perimeter of the base times the height of the prism. I'm outlining the perimeter here. We've got 36, 16, 20, 20, 16, and 36. And when you add up that whole perimeter of the building, you get 144. And the height of the prism is 10-foot walls. So that's 1,440 square feet. Sorry, I'm not quite sure why that's not fitting properly, but if I went dual page, there it is. All right, so a lot going on there. Rewatch if necessary if you don't understand where any of that's coming from. All right, and then the last thing here is we're going to ask you to go out and find a building at school or in the neighborhood that is a combination of simple shapes, sketch the building and its estimated dimensions, and then estimate the volume of the building. So you could just do this with your house, just kind of sketch it. If it's a multi-level house, just sketch the first level and then sketch the second level. Just kind of estimate its dimensions and go ahead and figure out its volume just by finding out the volume of the first floor, find the volume of the second floor, add those together. It's probably the easiest way to go about it. I think we could probably ignore the space in the attic, so the roof. So, or maybe you've got another building around town that would be easier. Perhaps like a silo. If it's just a cylindrical shape with like a cone on the top, that would be a nice easy one. Just add the volume of the cylinder to the volume of the cone. All right, that's all I've got for you today. Rewatch this if you need to. I'll see you tomorrow.